Here we are for AP Physics Impulse Momentum Problems number 3. It says, a 75 kilogram ice skater moving at 10 meters per second crashes into a stationary ice skater of equal mass. After the collision, they move as a unit, so they move together at 5 meters per second. Suppose the average force that a skater can experience without breaking a bone is 4,500 newtons. If the impact time is a tenth of a second, does a bone break? So here we go. Let's start with our picture. So we have a couple ice skaters, right? One of them is stationary. Here we go. Maybe she's doing one of those pirouettes or whatever on her skates, right? Right, arms overhead. You know what I'm talking about. Anyway, spinning around or something. Anyway, and then the second skater comes in at 10 meters per second. By the way, that is not slow. The other one comes barreling in. Here we go. All right. Okay, at 10 meters per second. Okay, that's the before picture. Afterwards, they're going to move together as a pair. Right? Okay, they're going to move together at some unknown. Nope, they're going to move together at 5 meters per second. Okay. And let's see here. They tell us, oh yeah, we know the masses are 75 kilograms each. And they tell us, they tell us the impact time was a tenth of a second. And we want to know the force, okay? The average force. So here we go. We're going to set up our little impulse momentum. I'm interested in the force between them, right? As they thump into each other, right? The force they push on each other with. So I am not going to treat them as a combined system, because if I did, the force of skater A and skater B, the force of skater B back on skater A, they would add to zero. They would drop out of the calculation, right? And so I have to look at just one skater. Well, if I had to pick a skater to talk about, let's do this one that was stationary, because there'll be a zero in that calculation. That'll be nice. So I'm going to do the stationary skater as my system. The initially stationary skater. And I'll do my impulse is the change in the momentum. And just that skater goes from being at rest to moving at 5 meters per second. There's definitely a change in momentum for that skater. So I'll have my final minus my initial, but the initial is 0 because we started at rest. The final is just the mass of the skater times that final velocity. You see, well, the mass of the skater is 75 kilograms, and the final velocity is 5 meters per second. So that side looks good. We got that down. The left side, see, I got this weird integral. Like, what's going on? Well, they told us we want to find the average force and compare it to 4,500 newtons. And so you say, well, average force, average in physics means if you have one constant value that gives you the same result. So average force would be a constant force. It would factor out of the integral. Constants factor out of the integral. And if I were to go ahead and integrate dt, that's just delta t. That's just the duration, which they told us was a tenth of a second. So my average force times a tenth of a second. Whoops. There, no one would ever know. Tenth of a second, right? So my average force is going to look like this, right? 5 times 75, you say that would be 375, right? Divided by a tenth, 3,750 newtons, right? I am right about that, right? 75 times 5. Yeah, I'm right. Okay, so 3,750 newtons is the average force, and it says, hey, the average it can experience without breaking bones is 4,500. You say, gosh, that's less than 4,500, and so that means we are not guaranteeing a bone break. All right, that's good. Okay. All right, that's problem 3. So like I said, the tricky part here is I'm trying to solve for the force between them, so I'm going to make the system just one of them. All right, so that force is a force from outside the system. That is the idea there. Okay. Yep. Essentially, if I did a force diagram for the skater, I suppose I should have before I did this. The only horizontal force, because we're going to assume that the friction between the skates and the ice is negligible here. The only real significant force is that force from that impact, and that's the one we're trying to find. It's the only horizontal force that would change that horizontal momentum. Okay, that's problem 3.